1 more than the given power. Alright? It's always 1 more than the given power. You look back in the previous example. For example, to the power 5, you notice you get 6 terms, correct? In the expansion. Number of terms is finite, yes, 6. In the expansion of a plus x to the power 4, you have 5 terms. Okay, so we have seen how we obtain this theorem, alright? The binomial theorem. That is a plus x to the power n is equal to this power series, alright? So now we take a look at the application of this theorem in binomial expansion. For example, this question, find the expansion of 2 plus x to the power 5 in ascending power of x, right? In ascending power of x. So instead of the multiplication method or using the Pascal triangle to obtain the terms in this expansion, now we use the theorem. Alright, we use the binomial theorem and write down all the terms, alright, in the expansion. So follow the theorem, this will give you 2 to the power 5, right? The coefficient here is 1, alright? You have 5C0, alright? It is 1. So if you don't write, also doesn't matter. Sometimes we need to save time, right? So we just put 1, alright? Then added 2, followed by 5C1, alright? You can write that as 5. Or you want to use calculator to work out, also can, right? 5C1, then 2 to the power 4, x to the power 1, right? The power for first term will decrease by 1 each time, and the power for the second term will increase by 1, alright? Correspondingly. So added to 5C2, alright? So you notice here will follow the power of x, alright? 5C2 2 x squared, right? Followed by 5C3, alright? 2 to the power 2, right? 2 squared x cubed, alright? So you notice when the power interchange, alright? The coefficient will be the same, alright? The 5C2 and 5C3 are equal. Just now I proved to you, right? The theorem, alright? So there's a symmetry in the coefficient of the expansion, right? Then added to 5C4, right? 5C4, 2 to the power 1, then x to the power 4. Then end with 5C5, which is again 1, right? 5C5, again 1, then x to the power of 5, alright? So you notice it's very much faster, alright, and easier to write down all the terms by using the binomial theorem, right? So I think you simplify yourself, right? Second example, let's say you're asked to find the coefficient of y to the power 5 in the expansion of x plus y to the power 9, right? To the power 9. So in this case, do you need to write down all the terms in this expansion before you determine the term in y to the power 5? No. Don't need, right? We can make use of the r plus 1 term, right? The formula for r plus 1 term in this expansion, alright? So to get y to the power 5, alright, it will be the term y raised to the power 5, right? So just write down the term in y to the power 5 will be y to the power 5, that is the second term raised to the power 5, right? If this is to the power 5, what about the power for the first term x? It will be equal to 9 minus 5, right? Because the sum of these two powers, it must always be equal to the power of the given binomial function, alright? So this is to the power 4. Hence, what is the coefficient here? 9. What is the coefficient here? Will be 9 C5 or 4. Either one will be the same, alright? Because of symmetry. So 9 C5. Alright? Then you can use a calculator and work out this value, 9C5, which will give you 153 x to the power 4, y to the power 5. Right? Hence, the coefficient of y to the power 5 will be the value in front. Alright? This is the coefficient of y to the power 5. So is it clear? Yes. So you notice using the theorem is much easier, right? Than the usual expansion or Pascal triangle, right? Now look at example 3. Determine the term independent of x in the expansion of this binomial, alright? X squared minus 3 over x squared raised to the power 10. So in this case, do you need to show all the terms and find the term which is independent of x? Don't need, right? We still use the same formula, alright? In fact, there are two ways we can do it, alright? The first method is using the formula for r plus 1 term in the expansion, alright? So in this case, let's say we write down the r plus 1 term in the expansion, which will be the second term, that is negative 3 over x squared to the power of r, right? The power of r. Just like I showed you, this power r is the r plus 1 term, right? R plus 1 term, right? Then first term, which is x squared, will be to the power 10 minus r, right? Correct? So that the sum of the two powers is always equal to 10. Alright? So it's 10 minus r. Alright? And the coefficient for this term will be 10 CR. Alright? 10 CR. Okay? So if this is the term which is independent of x, right? Then x to this power must be equal to the x term in the denominator, right? That is x to the power 2r, alright? Must be equal so that you cancel off the x, alright? To get the constant term, alright? Is it clear? So if this is the term independent of x, then we have, that is the power for this x, which is 20 minus 2r, right? 2 times 10 minus r, that is the index law you have learned in first topic, all right? 2 times 10 minus r must be equal to r, right? 2 times r, all right? Hence, your x term will be cancelled off, all right? That will give you 4r equal to 20, hence r is 5, alright? And r is 5, alright? By putting this r back, you get the constant term in the expansion, alright? Therefore, the constant term, that is the term independent of x, the constant term is equal to, alright? Tan C5, alright? Tan C5, x you don't have to write because it will be cancelled off, alright? Then multiply to negative 3 to the power 5. Is it clear? Negative 3 to the power 5. This is one way, alright, to find the constant term or the term independent of x.